Hi guys, welcome to Learning, and I'm Lavanya Elangovan, your science educator. I hope you all are safe at your home, right? Yes, so stay safe, look at all these online classes, take notes and revise those notes, right? So Learning is an online education platform where we give quality education for all students. Here at Vistaslearning, we help students to stay on schedule, give quality education, and also help them to excel in their academics. So do subscribe to our channel. And if you've already subscribed, please share it with your friends, family members, and relatives because somebody out there will have the access to quality education. So having said that, let's look at our session, right? Can you just recall and tell me what we were discussing in our previous session? It was your first chapter, matter in our surroundings. So what sort of matter is present in our surroundings? Yes, we can classify matter into 3 different divisions. Yes or no? So we'll just simply classify them as solids, liquids, and gases. Right? So these 3 are the 3 basic divisions of matter. And we also saw how are they arranged, whether they are tightly packed or loosely packed, and what is the energy they possess, whether they are free flowing, and all those things in our previous session, right? If you haven't watched that particular session, you can very well go back, get a clear idea on it, and come back. Or if you find okay, fine, no, I'm comfortable enough, let's move further, then we'll proceed. Yes? Right. So here in today's session, we'll be discussing about effect of change of temperature on all the 3 states of matter. Is this clear? So what is the effect of change of temperature? Right? Do you have any idea about that? What is temperature basically? And how is it going to affect the solid, liquid, and gas? I'll tell you. See, we'll just see first we'll start with the solid, and then with the liquid, and then with the gas, right? First, solid to liquid. So how is this solid going to get converted into a liquid? Just by changing the temperature? And for this, you no need a very big laboratory where you'll be wearing the lab coats and looking at all those chemical equations and combinations. You can just watch this change in your home. I'll tell you. See, melting of an ice cream. Ice cream, something which everybody of us like, right? Especially in summer seasons, we'll be longing to eat this because of the exposure to sun's heat. We want ourselves to cool down. Yes or no? Yeah. And this ice cream, until it is there inside the refrigerator, it will be in its own state. And the moment the ice cream vendor he scoops and put it on our cone, and when we are eating the particular ice cream, what will happen? It will slowly melt, right? How is this melting happening? Have you ever thought, why doesn't the ice cream just stay like that? Or the ice cube, why doesn't it just stay like that? Have you ever thought? Yes, there comes the answer for this. The heat. Can you see what is at the back of me, behind me? Yeah, it is so hot, right? Just by looking at this this particular picture, you can come to a conclusion that it is very, very hot. And here, can you see this? So this is a thermometer which is used to sense heat, right? In thermometers, again, we have 2 divisions. One, clinical thermometer, which will check our body temperature. And then we'll have the laboratory thermometer, which we'll be using in our laboratory, right? So that temperature change is influencing something. And as we are dealing with solids here, how solid is getting converted to liquid? Just by increasing the temperature. Think. You can very well post the answers. I'll be looking at your comments here. Yes? Thought? I'll tell you. See, listen. In our previous session, we discussed that the solids and liquids and gases have got a force of attraction between them. the interparticle force, right? And that particular interparticle force determines whether it is a solid or liquid or a gas. Yes or no? So in solids, what did we see? We saw that particular interparticle force is very, very strong enough, or it is at its maximum. Since it is at its maximum, it can just stay very, very strong. It is having its own definite shape and definite volume. Yes or no? So there the change happens. That particular interparticle force is getting disturbed, and that energy, we just say it as kinetic energy, right? So kinetic energy of the particle increases, which overcomes the forces of attraction between the particles. Is this clear? So as we are increasing the temperature, what exactly happens is the interparticle force is getting disturbed. So all the particles which is present inside the solid, let's take an ice cube, that will be easy for us. So inside that ice cube, what happens is like some sort of vibration happens. Vibration results in agitation, right? So the particles will start moving because of this increase in temperature, because of this particular kinetic energy. Is this clear? And that is why they'll be slowly losing their force there. And as they are losing their force, they will slowly get converted from solid to a liquid. Is that clear? So that is how this ice cube slowly melts, just because they are losing their force of attraction. Is this clear till now? So for all this phase change to happen, or from solid to liquid or liquid to solid, this change in their kinetic energy is responsible, because it is altering the force of attraction between them. Is this clear? So what exactly is melting? Melting is not just change of solid to a liquid, but the exact definition is this. I just wanted you to make a note of it. Okay, like as I always say, you can take a note of it, pause the video, write it down, or just take a screenshot and then make sure that you copy it in your notebook, because writing practice is a must. And you are in 9th standard, right? Obviously, you have to have a very good written practice. Only then your handwriting will improve, your speed will increase, right? And by the time you go to 10th standard, it will be easy for you when you are facing your exam, your board exams. Fine. Yeah. Melting, the process in which a substance changes from solid state to a liquid state. So that is exactly melting. Is this clear? Yeah. And for this melting to happen, certain specific temperatures are there. For example, and that particular specific temperature, you say this to be a melting point. So the temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. Is this clear? And this particular melting point will be different for different substances. Here we are dealing with water, right? So what will be the melting point of water? Any guess? Just come on. So inside the refrigerator, it is around -5 degrees Celsius, right? So once we are bringing it out, the melting starts. So what might be the temperature for that? Okay, I'll tell you. It is 0 degrees Celsius. Very simple, just 0 degrees Celsius. So once the solid state of water reaches the 0 degrees Celsius, it will slowly start to melt. Is that clear? Clear? So melting point of ice is 0 degrees Celsius. So now we've seen this solid to liquid conversion, right? So from solid, if it is moving to a liquid, it's obviously melting. Now we'll see the next, liquid to gas. The same water, it has been ice cube so far, and from ice cube it has changed to a water, and this water we have to make it to be a vapor like this. So what can we do? Very simple. We'll just take the water, keep it on the stove, and just we'll on the stove, right? So as the temperature slowly increases, what will happen? It will slowly become vapor, right? So vapor is nothing but the gas. So that is a phase change here. So liquid to gas. And for that liquid to gas, we've grouped into two, or we can classify them into two. Like we'll just say them as vaporization, and the two divisions like evaporation and boiling. So there is a drastic difference between evaporation and boiling. I'll tell you what evaporation is, okay? Yeah. Evaporation. See, evaporation is nothing but where the surface of the water just changes into its vapor. Right? So it is a surface phenomena which is happening just on top of the liquid, just like this. See, in water cycle when you are learning, you would have come across this evaporation, right? Where the liquid water just starts getting, it will turn into vapor. And as it is turning into vapor, it will just reach up as clouds. Very simple concept, right? So this happens as a as a surface phenomena. And it happens in lakes, ponds, oceans, everywhere. Even if you just take a bucket of water or just some small amount of water, keep it in sun, evaporation happens. And it's a slow process also. Yeah. See, I'll be explaining this evaporation, like in our next class, it's all about evaporation only. So this is just a gist, right? So next is boiling. So boiling is a bulk phenomena again, because in boiling, the entire content boils. Take milk, water, whatever, or even your mother is preparing sambar, right? So take that sambar. So the entire sambar will boil. Yes or no? Yeah, so boiling is actually a bulk phenomena. It, as I said, like we'll be discussing about boiling later. So what is exactly boiling? The process in which a substance changes from liquid state to gaseous state. Just like melting, but here liquid is getting changed to gas. And just like that, we are having melting point, right? So here we've got boiling point also. So boiling point, the temperature at which liquid boils to become gas at atmospheric pressure. Is that clear? Done with this? Boiling is clear, boiling point is clear? Yeah. So now, so solid, it melts to become a liquid. And liquid, because of evaporation or by boiling, simply we'll say like evaporation, okay, because of evaporation it will change into gas. Now we are going to see the next change, where solid directly jumps to become a gas. See here, if you are just taking an ice cube from the refrigerator, ice cube melts to become a liquid. And if you are taking the liquid, just boiling it or just leaving it in the sun, the evaporation happens. So the process flow is this direction, right? So as you are increasing the temperature, phase change happens stage by stage. Yes or no? But here, this is one of a very, like a magical change, where the solid directly jumps to become a gas. I'll tell you. Can you see this? What is this exactly? This is called as dry ice. You would have come across this word. Carbon dioxide, right? So here, the solid is changed, or it is getting converted to become a gas here. And in this particular phase change, this solid is not undergoing this particular phase of liquid. Instead, it will just sublimes, okay? So this process is called sublimation. So what exactly is sublimation? The process in which substance changes from a solid state to a gaseous state without undergoing the liquid state is called sublimation. Is this clear? See, here in this particular chapter, you will be coming across a lot of terminologies, one by one, right? So I just wanted you to take a note of each and every step. Is this clear? Yeah. So we've come across this: solid melts to become a liquid, liquid evaporation becomes a gas, and solid here, it sublimes into a gas. Is this clear? Can you see some other arrow marks also? We'll be discussing about this, okay? We'll be discussing the reverse process where we will be decreasing the temperature, right? Yeah. So what is this? I think you know what is this, right? Ice cube, simple. So how we'll be actually preparing this ice cube? Such a tedious process, right? No, not exactly. You're just going to take water, open your refrigerator, put in the, whatever ice cube plate or your tumbler, whatever. You're just going to keep it inside the refrigerator, close the refrigerator, right? So these are the steps, like how you have to prepare this ice cube, right? So what exactly is happening there? You are reducing the temperature. See, just imagine your room temperature is around 25 degrees Celsius. So, inside the refrigerator, it runs in minus, exactly the refrigerator there, the freezer box. It will be running in minus. So, there you are just reducing the temperature, right. So, that particular reduction in the temperature where liquid is getting changed to a solid, you call that to be freezing, right. So, yeah, freezing is a process in which substances change from liquid state to a solid state. Is that clear? Yeah. Clear with the freezing? Very simple, I'll just tell you again. Freezing is a process in which the substances change from a liquid state to a solid state. Okay? Just make sure that we are reducing the temperature here. I'm going to show another picture for you now. What is this? It's a very simple teapot. Yeah, I don't want you to look at the tea, but I wanted you to look here. What are these? Water droplets. How are they coming? Yes? See, how is your mother exactly preparing tea? Okay, fine, she is just preparing. Okay. Now she is pouring it into this teapot. She is just covering it. Not only in teapot, it happens in everything. Even if you are filling the water bottle, taking it out from the refrigerator and keeping it out in the room temperature, this happens. So how exactly is this happening? From where is this water droplets coming? Think. Simple. See, evaporation happens here. See, this particular tea will be very, very hot. Let's say 100 degrees Celsius, because that is the boiling point for water, right? So it is at 100 degrees Celsius. So you are just turning off the stove. Now the temperature is reducing. It is coming back to the room temperature. From 100 degrees Celsius, it is coming down, dropping down to the room temperature, which will be around 25 degrees Celsius, as I said before. Yeah. As it is dropping, what will happen? These gas vapors, whichever is here, it will start condensing, which means the gas is getting changed into a liquid there. Is that clear? So that particular process, you say that to be condensation. So condensation is a process in which a substance changes from gaseous state to a liquid state. And even here, make sure that we are reducing the temperature. Is this clear? Done? Yeah. So what is this? Any idea? Leaf is there, and what is this? The white outline here everywhere. So what is that? No? See, like the place where we are living, maybe this is not possible, but somewhere near the Arctic, Antarctic, it is possible. So what exactly is this? Any idea? Yeah. If you thought it is frost, then very good, you're a genius. Fine. So this is frost. So how is this frost happening? Here, some sort of change is happening, right? So that particular change, we'll say that to be deposition, right? I'll tell you the definition for deposition. Process in which a substance changes from the gaseous state to a solid state. Again, this is just the exact opposite of the sublimation. Because in sublimation, solid changes into a gas without passing through this liquid state, right? The same liquid state is omitted even here. Yeah. So here in this process, from the gaseous state, it is directly jumping to the solid state, and it is just omitting the liquid state. Fine. So this is deposition. Just make a note of this also. We'll just move. So is this clear now? Done? So solid, it melts to become a liquid, and liquid undergoes vaporization. Either it can be boiling, it can be evaporation, it will just go to a gaseous state. And solid here undergoes a process called sublimation, where it will skip this liquid process, it will directly go to this gaseous state, right. So now we will see the reverse process, where liquid, it freezes to become a solid, and here the temperature is reduced, okay. And this particular gas, it again reduces in temperature, and it will undergo this process called condensation, or it will condense to become a liquid here. Yeah, gas again, here it will undergo this particular process called deposition, where gaseous state will just become, or it will convert into a solid state. Is this clear with this? with this triangle, right? Good. Now we'll just move on to, we've done with this effect of temperature, right? Effect of pressure is also there. We'll just see like how pressure influences this states. Fine? Is that clear? So how is this pressure going to influence all these states of matter? Very simple. I'll give you one example here. Have you seen this? You would have seen this in your kitchen, right? Because in most of our home, this is the fuel for cooking process. Excuse me. Yes or no? So this is the major fuel for our cooking process. And what exactly is this? We say this to be LPG cylinder. So what is this LPG? Liquefied petroleum gas. I'll tell it again. It is liquefied petroleum gas. So here the gas, we are just changing the gas from its gaseous state to its liquid state. How? Not by altering the temperature, but by altering this pressure. I'll show you. See here, just look at this. Okay. See here what is happening, they are applying a lot of pressure. Don't just think like if we apply this much pressure it will happen. No, we need a lots and lots of pressure here. And when the pressure is acting on the gas, we can compress the molecules, right? Because in gas the molecules are far apart. They are just enjoying their own spaces. So when we are compressing them, what will happen? We are reducing the space between them. And we are making the molecules to come very, very close. And as the molecules are coming very, very close, they are becoming into liquid. And when we further compress them, we can solidify them. Or the liquid can also become a solid just by applying the pressure. Is this clear? So here, when we apply pressure on gas enclosed in a cylinder, it starts compressing and converts into a liquid. Is this clear? So how is this happening? Just by reducing, or we are just trying to remove the spaces between them. Is that clear? Let me repeat it again. So in gases there are a lot of spaces, right? So as we are applying the pressure, what will happen? We are just reducing the space between them. We are making the molecules to come together. And as they are trying to come together, it will turn into a liquid. And when we further compress them, it will become solid. Is this clear? And here we are not altering anything. We are not altering the temperature. We are just altering the pressure. And that is how this particular liquefied petroleum gas is stored as a liquid here. And it will be under high pressure. It will be just like liquid. Okay, so here there is a nozzle, right? So when it is attached to your cylinder, like your stove tube, what happens is like through this nozzle, very minimum amount of gas will escape out. So here the conversion happens, the phase change happens. The liquid will start becoming gas when it is coming in contact to the room temperature here. So unless it is present inside the cylinder, it will be in the form of liquid only. Is this clear? Fine? Yeah. So this is an example for effect of change of pressure on the states of matter. Yeah. So in this session what we were discussing about? We were discussing about solids, liquids and gases and how they are changing from their one state to another state. Right, and we also saw the triangle diagram, right? Like how solid melts to become a liquid and how liquid like undergoes evaporation becomes a gas, solid sublimation. Yeah, so just recall that. Yeah, so in our next session, we will be discussing about evaporation. And as I said before, evaporation is a surface phenomena which happens everywhere. Right, and again like evaporation also happens in our body. We will be discussing about all those things in our next session. So stay tuned, keep your eyes keen on Learning, and this is me Lavanya Elangovan signing off from Learning. Bye bye, take care.